3. All these three are categories of transcendental functions. First of all, let's deal with the exponentials as the first category of the transcendentals. Let's see. If we integrate exponentials, the exponents, what happens? Let's see our example number 1 as the integral of exponent of x dx. If we integrate this, if you integrate any exponent, it does not change. An exponent remains as an exponent. If you integrate the exponent of x with respect to x, it will give you the final answer as exponent of x plus its constant c. This constant c is our integral constant. Now let's go about to example number 2 and find out whether what I say that if you integrate an exponent, it means that an exponent has not any change. Let's see if we integrate the three exponent of x with respect to x, what happens? First, come and observe if you have any constant. Get that constant out of the integral side. This is what I'm talking about. Get our theory as the constant. Bring it out of the integral side and you have theory integral of exponent of x with respect to x. This is the same as this. That means our answer is going to be 3 exponent of x plus the integral constant, which is c. I think those examples are enough with the exponentials as a category of the transcendentals. Now let's go about to the category number 2, which deals with the logarithmic. Then here I'm talking about with logarithms in the transcendental functions. We met and talk about the being, the natural logarithm, which others call the in. Let's see what happens if we integrate a natural logarithm. We have here our example number 1. If you integrate the being of x with respect to x, what happens? Did you know if you integrate this, your final answer will be looking like x ln of x minus x plus c. If you integrate the ln of x with respect to x, this is what we get. Let's go further more with the examples and look at example number 2, which is the integral of ln of 2x dx. When we are integrating this, we are going to deal with the rule, which is u v minus the integral of this du. This is what is going to govern us. This is going to govern us when we are integrating the ln of 2x with respect to x. Let us observe our rule, or let our rule to be ln of 2x and then our dv will be x. Here we go with it. If we ln 2x is equal to u and our dv is equal to dx. Here we are going to substitute these into our formula in all our limits governs us integrating the ln of 2x and find out what the answer could be after integrating the above. Here we find the du dx. If you find the du dx from the ln of 2x, this is going to be the same as du 2x. But then you have to come here and differentiate the value here, which is put here. If it was 5x, then you would have multiplied here by 5. But since you have 2x, if we differentiate the 2x, we have that 2. And then you are going to observe that our du, dx from linear to x, is going to be equal to 1 over x. Now we come here. We want to find our v from dv equals to dx. We come, we integrate this side and also integrate here. If you put here the integral of dv equals to the integral of dx, I think everybody is able to observe that it's v equal to x. And so, then you come, you fully substitute these which are got into our family. And you're going to have the integral of ln 2x dx. But following will be our known, we should say that governs us will be that. Come here. U. What is our u? It's ln of 2x. We write ln of 2x, but times our v, which is x, minus the integral of v, which our v is x. We write the x, then times du dx, which is 1 over x. But all this is with respect to dx. This one will go up with that and will cancel. Then we will stay with our x, ln of 2x, minus the integral of 1 with respect to x. Then we are going to have it as x, ln of 2x, minus x, then plus c. But I think if we relate these two examples, you are able to see that even not undergoing all these steps, you can come and find the integral of ln dx dx, which will be x ln of 3x minus x then plus c. Everybody is able to observe. If you look on these two examples, you find out that the integral of ln of 3x with respect to x is the same as that. I think those examples are enough to read from the beginning. Now let's deal with our last category, which is the tree and inverse tree. We are going to first find out laws or note the first integrals of the trigonometry. And here I'm talking about the tan, the cot, cosec, those things. Let's start with them. That's our category number 3. Is talking with the trigonometry or the trig and the inverse trig. Here we are going to find if you integrate cos of x with respect to dx, what is the answer? If you integrate the sine of x with respect to x, what is your answer? If you integrate the tan of x with respect to dx, what could be your answer? If you integrate the sec square dx, what could your answer be? If you integrate the cosec dx, then the cot we have, if we integrate the cosec squared. Here we go with our examples. If we did with that, if we integrate the cos with x dx, we get a sine, but this sine is negative. That means we get negative sine of x plus c. Here we're going to get our cos of x plus c. Here we have the negative limit of cos of x plus c. Here we are going to have our cos of x plus c. Here is it that we are going to get our cosec x plus c. Here I have our cosec x plus c. So that. And we also have this if you integrate sec x tan x dx sec x plus c. Identify those, be able to note those. Because they are going to govern us as we do the examples dealing with it, all that stuff. Sorry. If we integrate the sec squared x dx, I think it's done. It's done before. Sorry for that mistake. It is tan of x. Now we are going to look about the examples that follow about that. 3. Our examples that fall under that trigonometry that we have talked about. We are going to see if we come and integrate the cos squared with the cos of this, and find out how we can deal with that. This one is the same as the integral of 1 minus sin to x with respect to x. If we integrate the cos of 2x with respect to x, we are going to have a half of 1 minus sin to x dx. Then we are going to ask ourselves where this comes from. Cos of 2x is the same as 1 over 2 into 1 minus sin of 2x. It's the same as that. That is it. Now we are going to do we get the cos, which is the positive. Now this is going to be cos over 2x. Then you differentiate this angle divided by the derivative of the angle, which is 2. We put there the 2. Then you're going to go then you get this. Evaluate that brackets on your exponent. That is going to be x over 2 minus cos 2x over 4 plus c. That is going to be our answer. This. Now you can also try this. If you have the integral of sin over 2x dx, our answer will be x over 2 plus sin of 2x over 4 plus c. Prove that. In your free time, you can prove that. You find out that the derivative of sin 2x